Guys, let's solve this problem, valid palindrome. Uh, just a quick reminder, palindrome is basically the same sentence if you see it forwards or backwards. So here, if you see the first four alphabets, AMAN, and you read it backwards, AMAN. So you can continue down the string, but essentially it's going to be the same backwards and forwards. And if that is the case, then it in fact is a palindrome. So in here, that is the case. That's why it's said to be true. This one, it doesn't look like it because you see RAC stacks fine up until now, but the fourth alphabet is the difference, E and A. Now, one thing is there are a lot of commas and spaces in between, so you got to ignore all of that. We just need to consider the alphanumeric characters. It says here, alphanumeric characters include letters and numbers, and remove all the non-alphanumeric characters. So this question looks like a two-part. We could have two functions. First, we have to start from the start of the string, and we also have to start backwards, so we could have two pointers. And first we could see, we could also convert this all the upper cases into lower cases, so as to have a consistent casing. So if we have a small a here and we've got a small a here, that looks good, but then we have a space, so we should not be considering the space. So we need to have a function where if this is a space, the left pointer just needs to move forward and stumble upon M. And then we can compare this and this, and A, and then N and N. And again, now this time we've got a comma. So again, comma is not an alphanumeric character, so it needs to move further. It does not need to compare this. It should not compare this, and it should go on until A. And that's when it finds a corresponding A. So enough said. We need to have a function which basically identifies the alphanumeric character. If not, we have to move forward, and then we need to have a two-pointer workaround. So let's do this. For the two pointers, we'll do it for the standard approach. We'll initiate both those pointers. So the left pointer starts at 0. The right pointer will start at length of s minus 1. This is the last character, and we'll say we'll have to run this loop until L is less than R, because once they cross, then the loop needs to stop. So what do we do here? So before we move further, let's because we have to increment L here and we have to decrement R. But we not only have to increment it and decrement it, we also have to be sure that it is in fact an alphanumeric character. So before we proceed, why don't we just create another function and call it uh, alpha? Is this alphanumeric? And we'll have to give it the self reference, and we are looking at a specific character, so call it C. Now to see whether it is alphanumeric, if you remember the ASCII code values, you could do that, but you don't really need to remember the ASCII code values. What we can do is we can simply return it as a boolean, true or false. And the way to do that is we can say if the C lies between these values, so meaning if this one, so let me type it first. So if this is between small a to capital Z, or, and we can just copy and paste this thing now. So if this is between small a to small z, capital A to capital Z, it's taking a little bit time, so bear with me. And then also if it could be a number, in which case we'll not use the single quotes. But if any of this is true, what does that mean? If any of this is true, that means it is in fact an alphanumeric character, so that's good. And not only that, not only the fact this is the first order of business, we need to make sure that it is an alphanumeric character. But once we have noted, for example, in this particular instance, just because it is an alphanumeric character, we don't stop there. We have to convert it into lower casing so that the casing is is common, and so that we can compare. But that's our next step. So what we'll say is, while L is less than R, and also while this, if this is not an alphanumeric character, so if the leftmost is not an alphanumeric character, then we just increase L by 1. All right, because we need to make sure both the left and the right parts are looking fine before we compare. Now we'll also have to compare while not. Why did I say dot here? It should be self, and the reason why we saying self is because we are referring to a function on the same scope. So on the class scope, so we can only invoke it, we can call it using the self. If this function was defined within this function, then we would not have to use this, but because it is on equal level, we'll have to refer to the object here under which it is contained. So we'll have to call it using self. That's how we have to do it in Python. And we can say self dot alpha num, and this time we'll take the rightmost character. So if the rightmost character is not alphanumeric, and because we are giving Boolean values, so not of this, so meaning if this was false, so then this would become true, and when it becomes true, that's when we'll decrement R by 1. And now the both of them will pass once the both of them are alphanumeric. So when the both of them are alphanumeric, that's when we have to compare. But the way we compare is not just S of L if this is equal to S of R, because we have to convert it into the same casing. So we can use this function lower, and we can use this function lower. Now they are in the same casing, we are comparing. And here there's a design scheme, but basically what it says is that rather than comparing it, we can say if this is not equal to, because if it's equal to, we'll continue to increment the L pointer and decrement the R pointer. But in the event it is not equal to, we can return false right then. So this is a little non-intuitive, because someone would generally want to say if this is equal to, because we are looking for an equal to. But what we have to remember is if this is equal to, then we don't have to do anything, because our loop will just continue running the way it's been set up. It is when it is actually not equal to, that's when we have to do something. A little non-intuitive, but it's a design paradigm, and just takes a little getting used to it. But we did this, and if the false is not returned in the entire loop and the loop exits, then that means that they were in fact equal, which is why the loop exited. So in that case, we can return true. Looks like this is hanging again, so bear with me for a second. All right, remove the white space. Looks good. Let's run this. Okay, so some error. Odd. Expected length of 1, but integer found out 0. Hmm. All right, so had a couple of couple of problems here, but I'll have to look into why we need apostrophes, why we need commas here in numeric values. And the second one is while L is less than R. If we do not put this again, it was actually going out of bounds. So we had to use this again, which is actually